Hi everyone, it's Kyle Brown again. We're going to be going through the remainder of the talk on application architecture for application migration to Bluemix that we were not able to cover during the training session that we had in Raleigh. And so what I'm going to do is I'm going to start off with the section that we ended with in Raleigh that we weren't able to cover, and that's the one on rebuilding applications for cloud centricity. Now, again, let me provide a little bit of background and context for this. Remember that what we're talking about is the general problem of how do you take existing applications and make them so that they will not just run on Bluemix, but run well on Bluemix. And we talked about the idea earlier that there are two types of ways you can go about this. You can basically do, I'm going to call it what's the minimum amount that you can change in your application to make it viable on the cloud. And we call that making it cloud ready. But the thing is when that's all you do, when you're essentially just making sure that there's nothing that won't stop it from running on the cloud, you're not taking advantage of all of the things that Bluemix can give you when you want to really write your application to run best on the cloud. And so that's what we're going to talk about now. We're going to talk about the idea of rebuilding your applications for cloud centricity. And first of all, I'll talk about what it means for an application to be cloud-centric, and we'll go through some rules and some ideas that we... So the first thing I want to talk about are some simple design principles for cloud centricity that all applications that are going to be really running on Bluemix need to think hard about as you're building these applications, or in this case, rebuilding your applications, to make sure that you're really taking advantage of everything that Bluemix has to offer. And essentially, there are a number of different principles that we could look at, but there's three in particular that I really want to spend some time thinking about. And that is that the Bluemix applications that are really going to be more born on the cloud and are going to, implement this notion of cloud centricity, have three in particular that are important, and then there's a couple of others that kind of follow from the first three. The first one, and probably the most important one that I talk to most of my customers about now, is that you really need to be thinking about building or rebuilding your applications. Now, this could be refactoring existing applications or implementing new features for existing applications in this way with what's called a microservices architecture. And I'll talk more in detail about what a microservices architecture is later. I do want to say that there's been a lot of noise about microservices architectures, and that as with so many things like agile methods and other aspects of building for the cloud, there's been an awful lot more heat than there has light. And when I really get down to talking to you about what a microservice is, you're going to see that it's actually just an evolution of existing practices rather than something that's completely and totally different. And there are ways of being able to take existing applications and refactor them to more of a microservices architecture that we'll talk about. The second thing that is absolutely critical is that really to take advantage of Bluemix, and especially the services that are provided for you by Bluemix and the associated things in Bluemix DevOps services, you really have to embrace DevOps principles in your application team. Now, basically with microservices, what I'm telling you is you have to write your application in a different way, and you have to package it in a different way. That has the ramification of meaning that you can't have your team do things in the same old way. And we'll talk about what some of those different principles are that are important as you look at refactoring your applications. And then finally, kind of to wrap both of those up, there is a well-known industry set of rules for cloud-based applications that I urge you all to become familiar with. And those are all available at 12factor.net. And in fact, it's a mix of application design rules and I'm going to call them organizational and team-based rules about complying to the principles of DevOps. If you do those three things, then in general, your team is going to be much better suited to being able to make your application really take advantage of the things that Bluemix can do. Now, there's a couple of ramifications of this. As we talk about microservices, one of the things I'm going to emphasize is the need to be able to develop small self-contained services that can each run in a different container or runtime in Bluemix. When you go down that path, as we'll see later, that has the ramification that it means you can make different choices about how you implement your different services. And because you have different choices, you can choose the right runtime and the right services for each individual service. That leads to a new concept in the way we build applications, and those are called polyglot programming and polyglot persistence. Polyglot programming is a change away from the way we've traditionally built large-scale business applications in the last 40 years. When, many people started in this industry, and, at this point that's the grandfathers and grandmothers of some of the people that I know in the industry, everything was built in COBOL. And so COBOL was the single language that, all business systems were built in. Well, during the 90s, that kind of shifted, and for a good 10 or 15 years, nearly everything was written in either Java, if you were a Unix and Linux type, or it was written in one of the .NET programs, in fact, usually Visual Basic, if you were a Microsoft type. And essentially those two ecosystems, the Java ecosystem and the .NET ecosystem, pretty much ruled the world, and everything was done in one language in each of those. Well, starting about 5 years ago or so, that really started to fracture. And now we are in an era of what we're calling polyglot programming, which means that different services in the same application can be written in different languages. And that meaning that you get some services written in Java, but some services written in Ruby, some services written in Node.js, and some of them written in Python. And that's completely fine, as we'll see later. Going along with the idea of polyglot programming, though, is another fundamental sea change in the way that we've been doing application development that really has started to emerge again over the last 5 to 10 years. And that is that up until the mid-2000s, if you were going to be storing data permanently or storing data for your application, you pretty much had one general type of choice. You would store that in a relational database. That had been true since the 70s when relational databases took over from the previous generations of databases of other types. And so what's happened is that has started to shift as well. And the shift has been with the introduction of what are called NoSQL databases, things like Cloud, but also Mongo, Redis, things of that ilk. And the ability to now choose the right type of database for the right type of data and the right type of data processing that you're trying to do is just as important as the ability to choose the right language for the type of processing you need to do in your service. And so these are some of the basic design principles that we're going to see are going to underlie a lot of what we're going to be doing as we really get our applications ready to run effectively in Bluemix. Now, what I'm going to go through is a design approach that really focuses just on the aspects of the application. Again, thinking about this as being either designing new function or refactoring existing function, but again, draws on much of our experiences that we've had in building applications for the Bluemix Garage and in building mobile applications with mobile first lab services. And essentially, there's kind of 5 aspects that you end up going through just looking at the application artifacts. And that is, first of all, and we'll talk about this more in detail, you have to understand your business goals. And after understanding your business goals, you have to understand what your target user experience is going to be. Once you have an understanding of that, now you're ready to really start thinking about the design of the application itself. The first step that I take with that is a new step that I've been promoting for the last several months, which is the notion of what we call archetypes. And I'll introduce you to what archetypes are. Archetypes are ways that help you select the right runtimes, the right libraries, and the right services and data sources based upon general principles that we've seen implemented in a number of different applications of these types. And you'll see what I mean when I get to it. But first of all, let's start with the top of this, and let's talk about the ideas of understanding your business goals and your target user interface. Well, what we suggest that you do with that is, again, not going to be too surprising. We would strongly suggest that you work with a team to implement IBM design thinking as the first step of any large-scale or even small-scale refactoring process in an application. Because the reality is that you really aren't going to be gaining a lot out of just moving your application to the cloud unless there's also a business reason to be able to move that application to the cloud. And that business reason is usually going to be driven, or at least is usually going to be enhanced by the ability to really understand what the right target user experience is for that application. I mean, we all know the effect that multi-channel and especially mobile are having on the way that applications are built. It's giving us a really good set of insights into how we ought to be interacting with our users in our applications. And that is really what is at the core of IBM design thinking. It's about understanding who your users are and understanding how they think and feel about the type of application that they're using and what it is they're trying to do with the system that you're building, so that you can get a better understanding of exactly what the right user interface design is going to be, and thus what the functions are that you need to implement to be able to give the user that appropriate user experience. So if you follow the IBM design process, and I would strongly again emphasize that you need to work with the IBM design team to be able to do that. You'll use the core concepts like hills, being able to figure out kind of what the major aspects of the system that you're going to be building are. Sponsor users, which are going to give you that incredible feedback that you need to be able to figure out exactly what it is you're building and how they're going to think and feel about your application. And playbacks to make sure that at every iteration you're actually validating that iteration and making sure that what you're building is the correct thing. That's going to really cement the overall approach in your customer's mind. And then you'll be able to use the other artifacts, things like empathy maps and wireframes, to be able to really give you the right experience that you're going to need to be able to build an effective application, and not just an application that the only benefit of is it runs different because it's in one place and it's now running on an IBM data center as opposed to running in a customer data center somewhere. So this is where we, again, very strongly emphasize you need to start. Now, after you've done that, let's say that you've re-envisioned your application or reimagined your application, and you have a really good sense now of what the functional requirements are because you've gone through the process of IBM design thinking, and you have some great wireframes, and you have some hills and some terrific user stories, and you know what that needs to be. Now you have to build the application. So where do you really start? I mean, this is the biggest question that we get with people looking at moving applications to Bluemix, is where do I even begin? Well, what we've found as I've sat back and I've looked at literally dozens, if not hundreds, of applications that have been built on Bluemix, both that we've built from our customers, that have been built by development and groups like EchoG and sample apps, and all the other apps that we could get our hands on in Bluemix. As we started looking through them and thinking about them, we realized that they fit roughly into a surprisingly small set of general categories. And those general categories I'm calling archetypes. And not surprisingly, there are 3 of them. And guess what? They are systems of record, systems of interaction, and systems of insight. Now, the cool thing is that within each archetype, when you just start grouping all of these dozens and dozens of applications into these 3 different categories, you really start to find out that the overall architecture of the application starts to look surprisingly similar. And so what I was even able to cook up is a formula that kind of describes almost every application I've seen that fits into one of these archetypes. So let's kind of go through each of them in turn and talk a little bit about what they mean. The basic idea is that you're going to have a set of runtimes, and then you're going to have a set of core services. And the core services are going to be the ones that are absolutely required to implement the functionality of your application. Now, this notion of core services is one that's been floating around the cloud, and especially the PaaS community, for a couple of years now. And what we've really done is just try to really take that basic concept and expand upon it, and you'll see that as I go through the next several slides. But to get back to the idea of our formulas that we have for archetypes, let's start with the idea of a system of interaction. A lot of the systems we build in Bluemix, not exclusively all of them, but a lot of them are systems of interaction. They're things like new mobile applications, new web applications that are going to be interacting with data in such a way that the user is going to be engaged with the application, and they're going to be manipulating that data or, gaining understanding from that data and then putting something else back. Some good examples of this are we worked with one customer to do a web survey application. We've worked with another customer to do an online shopping application for mobile. We've worked with yet another customer to do an application that was providing a healthcare advice type of applications where you could, put in some information about yourself and it would give you back targeted advice about the type of activities you should be doing and maybe, medications that you shouldn't be mixing together and things like that. Anyway, the thing is that all of these applications tended to have the same structure. And it kind of looks like this. First of all, there's one or more runtimes that are implementing a core set of services, and those runtimes are pretty much all running off a shared data store. Pretty much that's it. That's the core. But then you get these other things that are also very important and key to this archetype. With all these systems of interaction, generally you're going to have the core services, and then you're going to have, in many cases, a mobile gateway. And the mobile gateway is going to be the one that's going to be interacting with the, let's say, either hybrid or in many cases native mobile application that is going to be forming the front end of your application. So the mobile gateway could be something like the mobile first platform, or it could be even something simpler. In other cases, if you just need something simple like that, it could just be, again, the idea of a different set of services that are custom built that are very specific to the particular mobile application that you're building and, may just be for formatting information the particular way for that application. There are other types of gateways you may get too, and anytime I see something in brackets, it means you may get 0 to n of these things. A common aspect that we've seen in a lot of these are you need gateways to back-end data. So while in many cases you may be able to store some of your data on the front end inside Bluemix, much of the back-end data may be in your corporate databases, and you may need a gateway to be able to gain access to this. And then finally, you may or may not need data movement tools. Data movement tools are the ones that can basically switch data between your backends and your front-end databases, so that if you have, let's say, a cache of information, you need to occasionally be able to move information into and out of that cache, you need a data movement tool to be able to do that. All right, so if that's the idea of a system of interaction, let's quickly go through the other two. Systems of insight are a little bit different. They're the ones to where you have a lot of data. I hesitate to call it big data since that's become almost a cliche now, but you have a lot of data that you want to analyze, and you want to provide some understanding about that data by manipulating the data in some way. So that has a different archetype. You still end up with runtimes and data stores. The data stores tend to be larger. They tend to sometimes be more specific. So this is where, for instance, you might use something like, a time series database if you're storing Internet of Things data, or you might use something like DB if you're wanting to do pivoting and other types of data analysis for a data warehouse. But the differences here are that you also tend to get two other sorts of things on the end. Number one is the visualization. You're not going to be able to get insight out of the system of insight unless you have a visualization tool. Now that can be something as simple as embedded reports, which is one of the Bluemix services, or there's even a new service in the experimental services for generating simple things like PDFs. So that's a possibility, or it might be a more graphical visualization that you build in JavaScript or a native mobile application to be able to use some of the visualization tools that are available in a number of packages there. But the real heart of this is going to be the thing that's going to be doing that in-depth, detailed analysis. Today, often that's a tool based on Hadoop, and we give you plenty of options for that inside Bluemix. So we'll see as we get to those, kind of what those different options are and when you want to choose them, but that is usually going to be the core of that kind of analysis that you're going to be doing, that you're going to be then taking that new data that is generated from that analysis and then displaying and visualizing that to the user. So as you see, it's quite different from the idea of building a system of interaction. Well, then there's the final one, which is this notion of a system of record. Well, a system of record, again, starts with the idea of a runtime in a data store, but usually it's got a different gateway. And the gateway is because with a system of record, you are actually creating things that need to have a long, persistent lifetime and may also need to be transactional. So that's going to restrict down the set of things you do. For instance, you may want to use a transactional database like DB2 on Bluemix, or you may want to use the SQL database, perhaps something like the IBM SQL database or something like MySQL or something like that. You also probably want to use a transactional front end, something like, let's say, Liberty with a one-phase commit transaction. The key here, though, is you're generally going to have a gateway to either get the data into these transactional systems of record, or you're going to be having a gateway to get data out of these as a temporary store into a permanent back-end store. And the two types of gateways that we're often seeing there are the Internet of Things gateway, especially for bringing data in from all sorts of different devices into your system of record, or, again, a secure gateway or an API management gateway to be able to connect you back to back-end systems that are going to be either providing that data or moving the data out to something that's going to be a little more permanent and perhaps is existing back-end systems. Okay? So if that's the idea of these three archetypes, and you can pretty much just think about what it is your application is doing or different parts of your application is doing, because in fact, we've seen that single business applications can sometimes have different aspects of the application, different services that correspond to different archetypes. Once you have the idea of where your services fit in the archetypes, that gives you a little bit of guidance to then be able to pick the runtimes and the services. Now, the final piece of this puzzle is that not all services in Bluemix are these core services. There's additional layers of services on top of it, and we've been calling these two different layers of ecosystem services that you add to the archetype. If the archetype implements your core functionality, then the ecosystem services add things on top of the core functionality to help you fulfill either your functional or especially your non-functional requirements. So that's really where we're going to see the details as we start to get into the individual services themselves. So let's start with the idea of core services. Again, a good book that kind of introduced the notion of core services is the book PAS. It's from O'Reilly, and I can't remember the author right now, but if you just go look for the O'Reilly book named PAS, you'll find it, which talked about kind of building applications for Cloud Foundry, and they introduced this notion of core services, but they don't really talk about it in very general ideas of the fact that pretty much all applications are going to need something like a database and maybe something like a queuing system. Sure. Well, what we found is that there's much more to that when you start looking at how you categorize your services into different approaches. And this is helping you understand what it was I was talking about when we looked at the archetypes on the previous slide. One type of core service is this notion of data storage. Completely agree that there's things like that there. There's two different sets of data storage options you need to look at, though, and that's the SQL databases and the non-SQL databases, and we'll look briefly at both of those. Then there's the notion of gateways. We've already talked about some of these gateways and where you might use them, like the IoT gateway to be able to move MQTT messages from your IoT devices into your application and vice versa. We've also talked about the secure gateway as being a way to be able to make connections between applications that are running in Bluemix and applications that are running on your back-end platforms back in your data center. But there are other gateways as well that are just as important. API management for being able to get access to cloud APIs. SendGrid. SendGrid is an important type of gateway for just being able to send email. And that's a critical aspect for a number of applications for a special type of notification. Then there's also Twilio. So if you wanted to be able to send text messages or receive text messages, and that's very important, especially in countries where smartphones are not in the majority and feature phones are, being able to communicate by SMS is quite important in those countries, and that's where Twilio is exceptionally helpful for that particular aspect of being able to be a gateway from one type of interaction to another type of interaction. Now, earlier we talked about the need for visualizations and systems of insight, and we talked about embeddable reporting, and I also mentioned document generation as being one of the new experimental services for being able to build things like PDFs, but there are others too. Cognitive Graph is part of the Watson services, which is a great visualization of a lot of the insight that can be gained from those. And also, if you're trying to visualize the devices you have in your Internet of Things type of application, IoT Real-Time Insights can provide you with a lot of that information. Then there's all the analysis choices. As I mentioned earlier, the analysis choices tend to be, in many cases, based around Hadoop, and we give you multiple options for that. But we also give you things like DashDB, again, which I mentioned for data warehousing, streaming analytics for being able to do event-based processing, predictive modeling for being able to do predictive analytics, and that's based on SPSS. And then there's geospatial analytics, especially for dealing with geospatial data, and you need to be able to do reasoning about whether things are inside or outside borders and things like that. And then finally, there's a question of data movement and then data augmentation and data validation. And we have several different options there, but this set is growing as we add more data services into that set to be able to just, either move data from one place to another or add to data or translate data from one form to another. Okay? So hopefully this will help you get a handle at a very high level as to different things you can look for and different features you can become familiar with as you're trying to understand how to take a particular function of your application and break it down. But again, these are all around the core, just providing the functional aspects of your application. Around the core, there are two more layers of services that we also need to talk about. So let me talk about the first layer around the core of your archetype. The first layer is the notion of what I'm terming archetype ecosystem services. Now, these are services that are specific to a particular archetype. Now, in particular, where you see these happening are when you're building a system of interaction that is a mobile system of interaction, which means that you'll be using a lot of services related to that particular mobile system of interaction archetype, or possibly if you're building an Internet of Things type of application, and there are some specific services related to that particular archetype. Now, not only that, but if you're building web applications that are going to be just interacting with the user through standard web technologies, there are some particular services that are unique to that archetype as well. Let me give you some examples of this. So let's start with the mobile approach. If I'm building a system of interaction that is for mobile, and I know that I'm fitting that archetype, there are some services I may need immediately. One of them in the area in development is the mobile quality assurance service. You only need that if you're building a mobile application. It's useless if you're not building a mobile application because the kind of thing that it provides you, in particular the ability to do in-app feedback when a system crashes, is very unique to the mobile archetype. But it's also very useful when you have that, and it adds to the overall user experience of your application, even though it may not help with the core functionality of your application. Likewise, some of the mobile testing and mobile security types of services are very specific to that mobile archetype. And so you would only really look at them if that's the type of application that you're building. Likewise, if you are building a web application, and let's say you're building a web application using the Java Liberty runtime, then one particular service that you will probably need there is the session caching service. That's the application that that's the service that allows you to do service caching or session caching and session transparency across multiple instances of the Liberty runtime so that you can take advantage of things like autoscaling. Again, that's very unique to that particular archetype of systems of interactions when you're building these highly interactive web applications, especially on Java in that case. Okay? So you get the idea that certain archetypes, certain types of applications are going to have some types of services that only apply to that type of particular archetype. Then around that, in the second layer, there are things that I'm going to say are not specific to a particular archetype, but may be generally useful. You don't have to have them in your application, but they really help you when you're doing the building and the maintenance and the operations of your application. A couple of examples for that. Over here on the left-hand side, on development, I have a couple of our IBM's DevOps services. In particular, there's the DevOps pipeline and track and plan. You don't absolutely have to have either of those, but it makes the development and the releasing of your application much easier if you do. Over on the right-hand side, I have several of our security services, things like single sign-on or things like AppScan for different parts of your application. Again, you don't have to have either of those, but it makes your application much more operationally secure if you do. And then finally, down on the bottom, we have some that are specific to different types of performance testing and monitoring. So that can include things like our monitoring service or something like New Relic or autoscaling. Again, you don't have to have any of these, but they will make your application much more operationally robust. And it'll be easier to debug your application and easier to deal with problems that could occur in your application before they become real issues if you do take advantage of these services. And that's where this third layer happens. And when you're building an application, and this is what I want to get to in the next slide, it really is a set of steps that you're going to go through. Now, I don't want you to think about these archetypes as being boilerplates. You know, one of the questions I sometimes get when I'm explaining this is, oh, well, why don't you just make this a boilerplate? Well, no. A boilerplate in Bluemix is a very fixed set of services that always has to apply. And what I've shown you is that only some of these may apply in some cases, and you may have different choices. For instance, you may choose either the monitoring service or New Relic, but not necessarily both. Because we don't have the ability to make these kinds of choices in boilerplates, it's not appropriate to do this as boilerplates, even though you may get a boilerplate for some of these to start from for, you know, a small set of services that then you can kind of work from there. Now, the final thing that I want to talk about is just kind of the order in which you go through this. Well, the order in which you're going to go through this is basically you're going to start with looking at your archetype, okay? You're going to figure out which archetype does this application fit, and it may fit more than one because you'll have different aspects of your application that you build that are a system of interaction, and maybe a different aspect that you build that is actually a system of insight. They're both parts of the same larger business application, but they do different things. That's fine. They fit two different archetypes. Once you've picked the services and the runtime for the core of your archetype, then you can start thinking about the next two layers. You can start thinking about, well, do I need to add archetype ecosystem services unique to my archetype, like mobile quality assurance? Then, after you've done a few iterations using that service, you can start thinking about other services you may add, like do you need something to help you with maintainability, performance, or reliability, something like autoscaling. If that's going to be true, then you can go ahead and add an ecosystem service or two to help you in that regard. But again, notice that this is an incremental set of steps. You start with the core and you work your way out over a period of time. I would not recommend that you start trying to implement all of these at once because you'll just be overwhelmed. Especially when you're doing a refactoring of an existing application. You want to start with something small, maybe one particular set of services, work on that as an archetype core, and then start to build out the other services around it as they're needed. And that kind of leads me to the key tenets of the notion of microservices architecture. And this is really worth talking about in pretty much depth. Microservices are an idea that initially gained a lot of credence through a white paper that Martin Fowler published on the web a couple of years ago. And I would strongly suggest you go do a Google search for Martin Fowler microservices and read that paper. It's pretty short and it's easily digestible. There's been a lot more written on it now. There are a number of books out actually about implementing microservices, one in particular called Building Microservices that I would recommend. But they all focus on the same idea, is that, look, when we were going down the SOA route, SOA had some very good aspects to it, but it also ended up in a place that was possibly not so great. And that is because we weren't really able to separate the notion of the implementation of our services from the way that those services were packaged and the way that those services were implemented in the enterprise. In other words, we kind of brought some baggage along with the good idea that services brought. So what microservices are really an attempt to kind of restart the idea of services-oriented architectures by stripping a lot of things away and making them much simpler. In the same way, if you think about it, that REST was an idea of going back to the idea of HTTP-based services, but stripped away a lot of the excess that SOAP brought on that kind of complicated SOA in that respect as well. So it's in the same vein of just kind of paring things back to the core. And the core is really just these 5 things. The first thing is that you don't build large monolithic applications as a single packaged runtime. We've been doing this for years, and I never liked it. The idea of taking a single business application, which may consist of several dozen or even as much as 100 services, glomming them all together into a number of WAR files and then shoving all of those WAR files into an enormous EAR file that you then put onto a WebSphere ND server that then sprays it over a cluster 50 wide is not a great packaging structure because it has some issues in that it means that everything in that application moves at the same pace. Well, the first concept in microservices architecture is take those big monoliths and break them down. Not only write them as many small services with loose coupling between the services, but package them as many small services. Again, in a refactoring approach for Java, that may mean you take that enormous EAR file and you break it into individual WAR files, where each WAR file does a single thing, which is the second tenet, that services are optimized for a single function, a single business function that they do. In fact, you then take it to the next logical conclusion. If I have an individual WAR file that has one set of business services that do one thing in it, I package that in its own container, meaning it's either its own Bluemix runtime or its own Docker container. That is the level at which these things run, and that gets to the tenet that each service runs in its own process. Because if you're taking each individual WAR file or whatever other implementation you have at the same level of granularity in any other language, and you make that the level of packaging, that gets you to this idea where things can change at different rates. Now, in order to make this work, you have to set some standards. And the key standard that is not up for negotiation is there's only 2 ways to communicate with these services. You either communicate via REST or you communicate via a message broker, something like MQ-Lite or RabbitMQ. That makes it very simple to be able to communicate from one server or from one service to another service, and it makes them very transparent in the way that you are able to understand how things flow from one service to another. There's not a lot of things happening behind the scenes that you can't really see there. The one thing that it does suggest that you do is to avoid type coupling introduced by communication to a database. In fact, if you really follow the microservices architecture, one of the tenets would be is that you could make, again, using the notion of polyglot programming and polyglot persistence, a different database choice and maybe even a different runtime language choice for every single service. Now that's going to be extreme, but you can certainly understand why you can get there if each service is decoupled from each other, and especially they're not coupled at the database to where you're having them all communicate through writing to and reading from the same database tables. Yeah. Once we've gotten to this idea of having independent, loosely coupled